Hello, everyone. My name is Matt Barami from Wolfram Research. I would like to welcome you to the first session of our live coding series with Andreas Lauschke. We are very happy to have Andreas as instructor. Andreas will do live demonstration of key features of Wolfram language that are very useful in data science. I would like to add, Andreas has a master's degree in financial mathematics from the Technical University of Berlin. He has been using Mathematica since version 2.2, which is about 25 years ago. As you may know, last week we released version 12. Andreas' live coding sessions are entitled as Operator Notation and Application Data Extraction. Without further ado, let us welcome our instructor, Andreas Lauschke.
Yes, thank you, Matt. Thank you very much. I'm glad that I'll have the opportunity to show you a couple of sessions about using the Mathematica system. So today I'll start with the operator notation and show you a few data extraction applications. Indeed, it was quite a journey. I really started a quarter century ago with 2.2, and a week ago we got version 12. It's quite impressive. And it really has been the main programming language for the last quarter century of my life. So I will present about weekly, and we will incorporate your feedback over time. So we will specifically request your feedback. You can put it in the chat window, and in the future, we're also going to set up a section in the community where you can leave your feedback, and I will post notebooks, the homework, and where you can also submit the homework. My target audience will be beginner, intermediate, and advanced, not expert. I want to show people who come from different programming languages how easy it is to do powerful things with very few keystrokes in the Mathematica system. So one of the typical business objectives, right? Achieve a lot with very little, right? So I'm trying to show you how efficient the system is, how code efficient, how intuitive, and how fast computations can be. So this will be for beginners, intermediate, and advanced people who come from other programming languages and have seen their fair share of torture. And I want to show people how much you can accomplish with just a little bit of code. I will start with data science applications, and later I'll branch out to other areas of the Mathematica system, and we actively are asking you for what you would like to see demoed. So today I will talk about the operator notation. We have that since version 10. We will also use some pattern matching, not too advanced, but I'd like to show you what you can do with pattern matching. I think of it as a Swiss Army knife, right? Whenever MacGyver was trapped in a dungeon, then he needed some power tools and extricated himself. So pattern matching is one of the things you just have to be familiar with in the system. And then I will go to function composition. And the function composition is one of the building blocks that you should be familiar with when we come to the data set. And I will talk about associations and data set in the next two sessions. So I'm trying to prepare this with operator notation, pattern matching, and function composition today, and they will be very useful later on then for the associations and the data set. All right, so let's jump in it. The operator notation. So there is a short version and there's a somewhat longer version for it. The short version is for brevity and to prevent a lot of temporary and dummy variables. Many functions don't require you to specify an explicit input. So that can be functions like map, select cases, member queue, contains all, and brethren. So whenever we don't need to specify the input, well, let's get rid of it. Why carry it around when we don't really need it? And it feeds in very nicely then with the operator notation that we need and function composition that we need for more advanced applications. I have a somewhat longer version for you. So it's very code efficient, concise, and succinct. It makes code quite readable when it's not too long, not too verbose. Higher level programming concepts mean that you tell the system what to do, not how to do it. You want to specify on on what you want to tell the system, what you want to get accomplished. It is rather results-oriented when you can tell the system in a very declarative way, this is what I want. And if you want to handle variables and symbols, then that's a way of telling the system how to do things. But we'd rather see this as a higher level programming system. So we only want to tell the system what to do. This has a certain cognitive advantage. We don't want to go down into low-level loop constructs and program everything. It would be like version 1 or 2 of Java, right, which came from the mid-90s, where you had to program pretty much everything on a low level. So this allows you to do more science and less code, because that's what you're getting paid for. Presumably your employer pays you for doing the science and not necessarily for punching in code. The operator notation should be familiar to Linux users. It's called the pipe operator. And just like you would have in a pipeline, you shove stuff in on one side and it's coming out on the other. In a way, it's like a queue. So you have one operation, and the output of the one operation becomes the input for the second operation. Now you do something with the data, and the output of the second operation becomes the input for the third operation, and the output becomes the input for the fourth, and so forth. This is called the pipe operator in Linux, and Linux users are probably already quite familiar with it. You can think of operator notation as a form of currying, and I'm not going to go into that now. We may do this later, but I've included a clickable link that goes to the Wikipedia page of currying. It can help eliminate the hash, also called slot and ampersand, and function, explicit function definition of pure functions. It can sometimes eliminate map, but it's not always better. At the end of this session, I have a caveat that this is not the holy grail. There are many advantages to all these tools, such as map, pure functions, and part, that interfere with this control flow, but you should try to write in this functional style if you can, but it's not always better. It can also cause some problems. The advantages of operator notation accumulate as they can be daisy chained. So just like here, what you see here, you can daisy chain them from one operator notation to the next and the next and the next. Yeah? So the advantages accumulate. It can be used to improve efficiency, not just with a reduced leaf count, but also in lower algorithmic complexity. It can mimic natural language patterns. So I'll show you a couple of examples where it reads quite naturally, almost as if it's English language. It is extremely useful for the data set, and we'll see that next session, which requires functions provided as arguments. It is necessary for some of the features of the data set to see that. So the operator notation is like postfix, left to right, right? You start at the left, and then you have double slashes and go to the next one. So it feels like left to right, like we would read a natural language sentence. But when we evaluate it, when we compute it, then it is still seen as D of C of B of A, right? So when you start with, here you go left to right, right? I sometimes call it left to right, but here you're really going right to left. This is what the input form and the full form look like. So let's start with a simple example. We're all familiar with select. It picks out elements of a list for which a particular condition is true. This is the signature we've been using all the time. Select from a list based on a criteria. But when we are doing a function composition, then it's not necessary to provide that list, because by pipelining, it's clear from what's coming from the right or left. So it is, the traditional form is inside out, right? You specify as the first argument your input data to select, and the second argument is the criterion. So since version 10, we have the operator notation. Look at this signature on the help browser. It just says select based on a criteria. Well, where did the first argument go? We don't have to give it data if we pipeline it. So this now reads like postfix. We're going from left to right. So we start with a range of 20, and Then we go to the right, and then we just need to say, all right, select the even ones, right? And this is more natural, like a language. You can read this as start with a range of 20 and then select the even numbers, left to right. Prefix is like right to left, or you can also think of it as inside out. So here, when we can say select the even numbers, but then from what? I now have to give it an argument. I need to specify my data here of the range of 20, right? Same thing, but note that again, we have an operator notation here. I didn't have to tell select what the input data is. I just put it in front of it and gave it then the brackets to specify what my input data is. Same thing, it accomplishes the same output, but you can think of it as right to left, and the select itself is operator notation. All right, so now I want to show you some powerful examples. You're probably familiar with the tuples. Let's look at the 3 tuples out of a list of 3, and we can go fairly big here. Let's create some large example. The 6 tuples out of a list of 6, that's almost 47 list elements. And I'm now asking for all the palindromes. So I'm asking where the sublist equals its reverse. And in just a matter of a few seconds, we have all the palindromes of those 47,000 elements. And my point here is note that this is operator notation. Look how code efficient this is, right? This whole thing is like, what, 50 keystrokes? And in just a few seconds, I can get all the palindromes of a list of 47,000 elements. Now, these particular ones are not all that interesting, but I want to show the concept here, right? How code efficient and just how zippy everything is, right? Things just feel zippy, they come, they're ready, and you can accomplish quite a lot with just very few keystrokes. So we need a couple of other Swiss Army knives. One of them is cases, one of them is select. And cases picks out elements based on a structural pattern match, and select picks out based on a criterion that means true, false. So let's define a list of elements. And from this list of elements, we now want to look at all the integers. So it's not a surprise. We use the operator notation, and we just say my list / cases, and I don't specify the input. I just say what type I want. The integer, you can think of this as like a type. In other programming languages, you would call that a type. All right, so next, show me all the colors. So I just say cases that are RGB color. I don't have to specify any input for cases, right? It's clear from the list that's to the left of it. Show me all rationals, right? I mean, I could now go through all of this. This is about operator notation, not about looking at the types, but I think you get the picture, right? Also with the structure match here, cases of all the 2-element sublists. Are there polynomials in Y in these lists? And there's 2 ways to answer this question. I mean, probably many more, but one is to simply ask, do I have polynomials of this shape, of this structural shape in my list? Or I can ask, is the list free of anything of that structural shape? So again, I didn't have to give free Q or member Q any input. It was clear from the operator notation that it must be the list on the left of it. At what position is B in this? And we just use the operator notation. It's at positions 3, 6, and 10. At what positions are polynomials in X? Well, at 1, 2, 3, and 4 to 1, 2. So this I should probably explain a little bit, because these are nested structures. You can see that x to the squared is in the second position of the first element. That's why we get 1, 2. Then we have x raised to the power of anything in position 3. And here we have it in 4, 2, 1, 2. So we could go deeper into this, and then we see this here. All right, so position is one that has operator form, right? Keep those things in mind. You need to be aware of which of the functions that have it. And let's look at this in more detail. You can see that here you can see exactly where in this list you find anything of the shape power x to the underscore, right? We have it here, we have it here, we have it here. And let's drill a little bit deeper into this. What if we are asking for anything that is raised to anything, right? It's like a polynomial in anything. And you will see that here we have an additional 4 too. Why is that? Well, we have one here, x raised to the second is 1, but this entire expression here raised to the 4th, that's also something of the shape, something raised to the power of something, right? Or anything raised to the power of anything. So position is 1. Keep in mind, position is 1. But operator notation is not possible for functions that take several arguments. For example, position when I have 3 arguments here, when I have a pattern and a level specification. So if we look at this up to the first level, we get only 1, because this is the only one that is a polynomial in x it by itself. Up to the second level, all right, here we get a little bit more. 1, 2, 3, and 4, 2. And only the second level, in that case, you put the 2 in braces, then you get another solution, right? 1, 2, and 4, 2. Notice that the 3 is missing here. That's because we are only on the second level, which would exclude this one. X raised to the 4.2 would not be on the second level. So position is one of them, but keep in mind, if we have more than just one argument, if we need 2 or 3, then operator notation is, of course, not possible. So you have to keep that in mind. It works only on functions that only have one argument, and they're called univariate functions. Many functions have only one argument, univariate functions, and they still behave as if it were operator notation, right? Not the conjunctive case here. So length is one of them. Length of a list, well, it's pretty clear what that's going to do. It's giving you the length of the list, so you don't need to tell length an input argument. Sort works with one, right? Sort can be univariate. Sort of a list, well, there's your sorted list. You can transpose, right? The first argument of transpose is a matrix, so you can use transpose that way. So transpose can be a univariate function. Determinant, right? The argument of determinant is a matrix, so if you give it one, you don't need to give this input data to the determinant anymore. All right, how many B's do we have in that list? Count is one. So when you run count, you see how many B's are there. Again, I didn't have to specify for count how many inputs, what the inputs are. I don't want to beat a dead horse. I don't want to belabor the point, but I want to show you several simple functions, simple operators that use operator notation. So that's why I'm showing you all these: length, sort, transpose, that, position, and so forth, right? Contains any is one. So this asks the question, does this contain any of this list? Is there any of ABC in that? Yes. Contains any of ABC? No, because neither A nor B nor C is in it. Does this list contain all of these? A, B, yes. This contains all of them, A and B. Does this list contain all of them, A, B, D? No. Not all of them are included. For example, D is missing. All right, next, I want to show you that this interfaces seamlessly with the function composition. You can define your own criterion for select, for example. This would sum all the elements of a list, and it gives you true if that list, if the total of the list elements is less than 100, right? This is a Boolean expression. This here is a Boolean expression. And we turn it into a pure function for f. So let's create a 100 times 3 matrix. We want 100 random integers up to 100. And now we are applying our criterion. So what we do is //select of f. Again, we didn't have to specify the input. It's incredibly powerful when you can just define your criteria or your patterns for pattern matching and then just use them, right? So you could continue from this. This is what we started with. And in order to make our selection, all we need to do is add this one and we're done, right? Very code efficient, this operator notation. We can daisy chain it. So factor all the even integers between 56 and 100. So we start with a range of 100, and this reads like a sentence, right? Take a range of the first 100 integers, then select everything that's even, then select everything that's larger than 55, and then factor that stuff, right? So it's very easy in operator. This is completely an operator notation, right? This is operator notation. This is operator notation. Factor integers and operator notation. So it's equivalent if you put, you can put these together, these two selects, right? Select one, then select the other. You can throw them together here. It's the same result. You can also use right to left, right? You can start with the range of 100 here, then you select and then you factor them. But this doesn't read like a sentence, right? How would you read this as a sentence left to right? Factor the integers that come out as a result of this select with two criterion starting with a range of 100, right? This is some sort of interpretation that you would have to do if you were to read this as a sentence. Or you start reading it right to left, but that's not always all that convenient, whereas this reads pretty much like a sentence. All right, that brings me to function composition. The operator notation is particularly useful when it's applied in function composition. And we'll see more of this during the next session when I'll introduce the dataset. The dataset makes heavy use of operators, and so does query, and dataset uses query internally. So I strongly recommend you get familiar with operators and operator chaining, operator notation, operator form. It's sometimes called operator form. Composable functions is one of the main pillars of the functional programming paradigm, because in functional programming, you typically provide functions as arguments. And that oftentimes involves the function composition. All right, to emphasize this point, I'm now showing you an example where I'm defining such a function purely based on operators and no input yet, right? So I define a function select. And select now does the following. So when it gets data, it selects the even numbers, then the numbers larger than 55, and then we factor that stuff. So when we look at cell in the full form, we see that the kernel understands this at the right composition of a select and another select and a function based on a slot and so forth. And then the last one, factor integer, right? So when you see composition, think of it as, the kernel thinks of it as a function, right? There is no data here yet. So select is purely defined as a function. Where's the data? There is no data. I didn't give it any data yet. I still have to do that. So select or SEL would now be a function you could provide to some other function as an input that makes it functional programming. All right, it doesn't have any data yet, so I have to give it some food, and then we can get the evaluation of it, right? So make the selection from a range of 100. All right, right to left is also possible. And this is very powerful when you're using the dataset, because in the dataset, a lot of it you read right to left. So here I'm first selecting the integers larger than 55. Then I'm selecting the even ones, and then I factor that stuff. So now cell gets redefined, and you see that it's different. And now I can use this new SEL on that range. Also, let's look at the full form of this new definition. And we see it's now a composition, whereas this one here was a right composition. right? Notice the difference. So these are functions that are defined differently, but they do the same thing here. All right, I want to give you a brief summary before I proceed to the application for this session. So inside out without operator notation means you may have to do some bracket surgery during your debugging. It's sometimes hard to see. Sometimes you don't know where you would start. You may have to change the order of the operators. You may have to add or remove operators. Can be quite unpleasant. You can make plenty of mistakes there. Can be quite unpleasant. So that's what the operator notation simplifies for you. And again, particularly useful when it comes to function composition. So now comes an application that I want to show you, a very simple one. I'm trying to find something that is simple enough that it can be done with a few keystrokes, yet complex enough so that it represents real-world data. The Deutsche Börse AG provides all the etc. and the Eurex transactions. The etc. transactions are the electronic stock transactions in Germany, but also neighboring countries like Switzerland and a few others. The Deutsche Börse actually merged with the Swiss Stock Exchange, and etc. is their electronic trading platform. And Eurex is the electronic options and futures exchange, and it is owned by the Deutsche Börse. So we have these as two separate platforms, but all together. And this data is hosted by AWS on an S3 volume. If you want to know more, you can go here to the AWS registry for open data and look up the public data sets of the Deutsche Börse AG. And there's also a documentation page. So I already mentioned pattern matching is a Swiss Army knife. And I make extensive use of that here. The following section will all be a good refresher for you in terms of pattern matching. You have to know it. You have to know it to make advances with the Mathematica system. If you know it already, this is probably just a good refresher for you. If you don't know it yet, learn it. So I'm creating a new directory for the past data. The earliest data I could find was actually the 18th. I suspect this was not updated yet because of Easter. So usually they have the previous day, and I did this notebook like 2 weeks ago, so I'm still saying yesterday. Think of yesterday as April 18. So another useful function in the Mathematica system is create directory. You just create it and it's there, right? And if you run it again, it will throw you an error message. It says, I cannot create one for you, there is already one. I don't like permissions of 777, so I changed them to 700. You can also get down to the bare bones. That's another big advantage that I absolutely love in the Mathematica system. You can just say run, and then comes a complete Unix command, right? I make directory with the date string, then I change the permissions, and this is my target destination, right? This is where I have my target. All right, now we are ready to download the files. The etc. files and the Eurex files are at these URLs. They are provided by S3. You can see they are on Amazon AWS versions. URL download is a relatively new function, I believe version 10, 11. I actually don't know when it came, but it's very useful because you can now download files with code. So you see just a few seconds, and we have downloaded everything into that directory. And let's look at the stock trades. So I imported. These files are organized as 24 files per day, every hour, right? They provide one CSV file per hour. So I want to have all of them together. So I flatten them on level 1, and I delete all the headers when I want to look at all the data, but I also want to look at the headers once. So here are all the headers of these files. And for example, I can now say file number 9. So that's from 8 o'clock until 9 o'clock in the morning. Show me all the Lufthansa activity between 8 and 9 o'clock. Right? So here I get probably a big table now. All right. So this is the Lufthansa activity between 8 and 9 o'clock. So a bunch of trades. All right, next I can say, give me a price chart of Lufthansa between 8 and 9. So again, this is just the data that I have in a table. Operator notation for cases, right? I didn't have to specify here what my input is, and pipe it to the next, give me a list line plot, right? List line plot takes a simple list line plot, so it's univariate. If you want to use, you don't have to use it univariate, but it has one signature that is univariate. So I can just daisy chain them here. And again, I don't get tired of saying it. Look how code efficient this was, right? One line and you immediately get a list line plot of the activity price chart. Try to do that in another language, like in R or Python or SAS. You're banging your head against the wall. All right, let's look at the price chart for Lufthansa for the whole day, right? So the data is an all data, and I do the same thing, and that's Lufthansa for the whole day on the 18th. Show me the min and max prices for Lufthansa. So here I am extracting from the third last column, right? You remember that I showed you the table headers, and we see that. Let's have a quick look at it again, right? So we have the symbol in the second. We have the name. The security description is the name. It's in the third column. Then comes the type. Then comes the currency. And then comes start price, max, min price, end price, traded volume, and number of trades. So with this in mind, I can now extract. Oh, I've used it already here, right? This means the third last column. Sorry, I didn't mention it earlier. This is the last column, the second last, the third one. I extracted, converted to A and to the list line plot. So the min-max prices for Lufthansa here, we have them again in the third last column. All traded instruments, and how many are they? So that would be in the third column. And these are now all the symbols. And I'm using short here because it's quite a lot, right? I don't want to have 2,300 long strings on the screen right now. I can also ask how many they are. Well, then I just take the length of the union and we get 2281. That's the number of instruments that traded on the 18th. I can now look at the shortest and longest company names. Again, look at this. It's always // and then comes a univariate function. So let's look at the shortest company names. And minimal by is another one, right? And string length is the function that I use here. So this is functional programming because I gave a function, string length is a function, to another function, namely minimal by, right? And I pipe everything left to right. So the maximal version is pretty long, right? They have, I think, a limit of 20 characters or so. So I'm not going to show you all of this output. I'm going to delete it. But this is how it goes, right? Almost reads like a sentence left to right. All right, Lufthansa volume and number of trades for the day. So we have this now in the second last column, and we have this in the last column. So I'm extracting it with this pattern. So this shows you the volume, and this is the number of transactions. All right, let's do more of this function composition. Which companies are Kommanditgesellschaften of Aktien? Those are the stocks that have KGAA in the name. That's a particular type of stock. I'm not going to go into that. It basically means that you can be a family business, but for the outside world, your company is still a capital stock or incorporation. Kommanditgesellschaft of Aktien. So also, again, very code efficient. We start with our data, we take the third column, we take the union of them, and then we select operator notation, and string contains Q itself is an operator notation, right? String contains Q is an operator notation, and I give it as input to select, which is an operator notation, and so forth, and so forth. I think I'm beginning to beat a dead horse here. But that makes it, again, very code efficient, and you can get the results quickly. Again, just a few keystrokes, And here you see several companies that have started out as family business. You see medical companies here, Fresenius Medical Care, Merck Bank is a known family business in Germany, and so on and so on. All right. So I did 3 times operator notation here. All right. No recorded price change during a minute. You can now use more advanced functions, pure functions, and a few other things with select, with cases. So what this means is that the min price, max price, start price, and end price, those were in the 3rd last column, 4th last column, 5th last, 6th last column. And I have to say thank you, right? That checks if all these numbers in the following list are the same. And if there was no price change, then all 4 numbers are the same. So I just apply, this means apply, this is a shortcut for apply. I just apply thank you to these 4 element sublists. That's my selection and the length, compared to all of them, which was almost 71,000. And show me that as a percentage. And we get to see that about 60% had no price change. All right, what security types traded on, etc. on the 18th? Well, we take the 4th column. You will remember that the security type was in the 4th column. And I'm only using short because it's a long list. All right, you see that it's a ton of them, and I just want to show you the short list, the result of it. One thing that I sometimes like is that I take total of different things. So then I can see 53,000 common stock, and it was 1,300 ETCs. It was over 16,000 ETFs, 552, and 60 others. All right. This is somewhat, you can think of it as quick and dirty, because this plus sign here really is a mathematical plus. It's not, perhaps you may say this is not proper to distinguish, but there are simply things that do not come together. It's like adding apples and oranges, right? You can say apple plus apple plus apple plus orange plus orange. And when you totalize this, then you get 3 apples and 2 oranges. So that's what you see here, right? That's what you see here. It's one way to show you how many of these types were, right? So we're interested in the counts. We want to know how many there were. And there is a nicer form, a short form of this later that we will visit when we come to the associations. We can have this much nicer here. You will see already in the association here, you don't have these plus signs, right? This is really somewhat cheating here, but in the association, which I haven't introduced yet, but comes next week, we see that it's 1353 for ETCs, and so on, right? This means the counts per unit. How many counts are there per unit? And again, trying to beat the dead horse, look how code efficient this is, right? This was maybe 20 keystrokes here. All right, so now let's look at the futures and options, and they are in the XEUR files. So I need to load those. And here again, I want to get rid of the headers, and therefore I need to flatten them to the level 1. Let me show the headers, and let's look at them. We will need them later. The 2nd column is the market segment. The 3rd one, the underlying symbol. The 5th is the currency. Then comes the security type. Then comes the expiration, strike price. If it's put or call on an option, then we have to say if it's put or call. The strike price, only the calls and puts have, only the options have a strike. And well, then we have the usual stuff that interests us at the end of this list: start, max, min, end, number of contracts, and number of trades. So show the DAX activity between 8 and 9 o'clock, right? So we have DAX in there, and we have 655. The DAX futures activity between 8 and 9. So now I have to specify specifically that this is a future. We have this here in the security type column. We have FUT for futures and OPT for the options. All right, deducts options activity between 8 and 9. So what you do then is that you just get more and more restrictive in the pattern matching. And then you get your filtration. It's in a way like filtration. Give me a price chart of the DAX future for the June expirations from 8 and 9. So futures have expirations, and the next one is the June expiration, and that comes directly next to the security type, which would be then this filter that we use, and I'm extracting the third last column and pipe it to list line plot, right? Simple, left to right, a lot of operator notation here, just works like a charm. I will point out that security type is, strictly speaking, not the right word. Options and futures are not security type, are not securities. But this is a terminology that is unfortunately used worldwide. They are not securities. And for the whole day, all right, all I need to do here is switch to all data. I think I'm using the same query. And this is the DAX future, the June expiration, the price chart for the whole day. All right, pretty quick, I think, right? And you see that these results come instantly. There's no such thing as a 5-minute computation, right? It's very interactive. It's very zippy. How many DAX put contracts traded during the day? Yeah, so we don't even need to specify put and opt in this, because only options can be put or call. How many DAX contract trades during the day? That's different, right? Because the number of trades is not necessarily just one contract. This is obviously much less. So this is the number of trades, and this number up here is the number of contracts. How many strikes are there in the DAX June expiration? So I can take out the column that's between the expiration and call put. I do this with a pattern matching here, and I take the union and the length of them. Or I can go directly to the union if I want to see which ones they are, right? And the total of this then is 72, but I can also look at which ones they are. And I'm sure you will fall in love with counts once I have introduced the associations next week. This is another form to see how many counts I have there per strike. So the 11,950 had 3, the 11,850 had 3, and so on. The 8,000 only had 1. The 12,100 had 16. All right. We don't need to filter for opt anymore. All right. I said that already. We can throw it out. How many DAX future expirations traded? I think it's 3. All right. They always list the next 3. And the expiration is always the last month of the quarter. So it's March, but we already passed March. Then comes June, then comes September, then comes December. And the day is always the third Friday of the month, right? So this could be some homework. Write a function that computes the third Friday of the month, or write a function that tests whether or not a given date is the third Friday of the month. All right. All traded instruments are in which currencies? So we can just take the union, that gives us the list. We can do the cheaper version, that's the total, or we can use counts. That returns an association of the counts per currency. All right, next, let's look at which currency the DAX future trades in. Well, it's obviously the euro, trades in Germany, and Germany is euro. Note that it was, I should perhaps make a session about pattern matching. The way you extract that column is that it's the second to the right of the symbol, right? So the currency is 2 columns to the right of the symbol. That's why I have DAX here, 1 matcher, and then A, which I extract. All right, what are the market segments? So this is also gonna be a long one. I should learn to evaluate the right cell, and then we can look at them. Again, I'm using short because it's quite a lot, right? I don't want to, it doesn't matter what they are, but I want to show you that just with all this pipelining left to right, you can get this pretty powerful. All right, how many % of the same price in their respective minute brackets? Okay, this I've just taken from the stock version. The third last, fourth last, fifth last, sixth last, you apply same Q over M, and that's your selector. right? Very zippy, very code efficient. It's just a dream to get this quickly. And it's now 74%, which is pretty normal because options don't trade as fast as stocks do. All right, but I just want to say, I just love part as well. It's very useful if you know the column, but that's also the problem, right? If your table is fixed and you know the column, then using part or the double bracket notation can be incredibly fast. So this is the shortest of all of this, right? And we have the security types at Eurex are futures, options, and multilegs. In the United States, we typically call them spreads. At Eurex, they call them multilegs. The spread is when you have an option strategy that has more than one leg. We call them spreads. Here is multilegs. And again, the total version and the counts version. All right, I'm coming towards the end, and near the end, I want to give you a bit of a caveat. The operator notation is not always more succinct, especially when you can use part or its abbreviation. This is often more succinct. For the currency example above, you don't even have to do the rule replacement if you use part. But now we're back to prefix, and I'm saying not that this is a bad thing. Right? The operator notation is not a holy grail or a solution for everything. So we can also make it pretty short and succinct if we just grab for the fifth column, right? No, I don't need to do the rule replacement. But in this form, it's no longer operator notation. Well, boohoo, it doesn't have to be, right? And part has no operator notation. You could now force the use of the operator notation in order to enforce left to right. But by changing this, it may look quite unnatural, right? Does this look pleasant? You start the operator notation, you go left to right, but you need to set parentheses. And just because you need to make sure that part binds closer than union. So using the bracketing notation is more work than not using operator notation. The problem here is the operator precedence of part. And I think in the future, I'll talk about precedence as well, which is higher in the precedence table than postfix. Still keep part in your mind as another Swiss Army knife. Oftentimes, the high precedent is extremely useful. It allows you to interfere with the regular evaluation flow. And that is good when you know how to use it. And of course, when you don't know how to use it, you're messing it up. It's important to note that part binds with higher precedence, right? But that can be very irritating when you use postfix, which has relatively low precedence. And I'd be glad to say more about this if you want. As I said at the beginning, we are requesting your feedback. So I show you quickly the table for this. There is a operator precedence table in a tutorial in the help browser. And you can see that part binds to the right, and the prefix binds to the left, and then the postfix binds to the right again. So this is an extraction from this table. And keep in mind, there is a hierarchy in this, right? This is the order, first row, second row. This is only these three lines, but keep in mind, the higher one is evaluated first, that is part. And then the lower ones, and then the lower ones. It's a long table. It's like 100 elements or so. So I've only shown you those three, but there is a hierarchy, all right? First row, second row, third row. So this also means that postfix is evaluated after prefix, right? Because this line stands above this line. So when we look at this is really C of A of B, right? So keep this precedence in mind. So there's nothing inherently wrong with prefix, right to left, inside out. For many people, it still reads quite natural. And it's also closer to mathematics itself, where we typically write a function as f of g of h of x, right? To understand it, we sometimes start with x and then we go right to left or inside out. But there's nothing wrong with this. And this is actually the more mathematical notation. And another thing that can help you, the front end gives you the wonderful ability to just click yourself outside, right? So I do a double click on all data, or I do a double click on these braces here. And you see that the next surrounding context is cases. You see this highlighted here as if this were a yellow marker. So now I can go on. I do a triple click. 1, 2, 3. 1, 2, 3, 4. Now we see the cases, right? And so on and so on. So you can, by clicking, you can get yourself from inside out. There's also something with tabs. I don't use it with tabs. I prefer to click myself outside. But it is always there to help you if you don't want to do this operator notation. If you get lost, you can always click it, right? This was just a quadruple click. Let's do a quintuple click. That had the part in it, and then the sextuple click would be covering the union. Also, operator notation can appear very nerdy. We could, in theory, write 100, no, give me a range of it, and then factor that stuff. It looks kind of bizarre and nerdy, I think, right? It reads much more natural when you say factor the integer of a range of 100, right? Same output. This is totally nerdy, but it's valid, right? Because range has one syntax, it has one signature that accepts just one integer as input. So you could entirely write it like this, but how would you explain it to someone? How would you read that sentence? I start with 100, give me a range up to that number, and then factor it. That's just rather unnatural. Whereas this looks, it reads much more natural, right? It's much easier to read and write to understand. So I hear with decree, postfix is not the end of the world, and operator notation has its limits. Okay, so this brings me at the end of it, and at the end of my script on postfix, I give you a postscript, and I proceeded with a nerd warning. Here is a hack to find out all functions that have documented operator form. Well, this takes like 10 seconds. It has to do a lot of search through the entire documentation where we're looking up the usages. But keep this in mind. This is a bit of a nifty hack to show you all the ones that have operator notation. And this should finish. This should finish quickly. Yep, there it is. And you will notice that take and drop are not in that list, all right? var arg functions cannot possibly have operator forms. But for take and drop, it would in theory be possible. And I think maybe in future versions we're getting it. But at least for take, I found a hack. You can use extract. So if you insist on using this operator form, you could even make something for take for that, right? So you start with 50, turn it into a range, and then take the first 20 of them, and operator notation, you get 1 through 20. Obviously, it's the same as taking it directly in this form, right? 1 through 20. So, and this with take quick. Does not work directly.
Andreas,
yep.
We have a few minutes. I think, it's time to wrap up, and there are only a few questions. Yep.
And I just have 2 more lines. How's my timing? I timed this for 6 p.m. and it's 6 p.m. right now. I'm done in a few seconds. So you could now define your own take functions if you want to, if you're so keen on it, right? So you could use this take init. But again, I think it's kind of pointless. It's a hack. If you insist on having take as an operator notation, generally you will find systems that you will find a way to make this nicer, but it's available, right? You can always write your own hack for this if you insist on it. I think take and drop should be in this list, and I think we probably get them in future versions. So, but keep this list in mind. It's a nice hack to find out which ones they are. So this brings me at the end of my session. I have some homework for you. Use pattern matching cases, select unilength, total, whatever you want for these following homework questions. So I start very simple. Show all prime numbers between 100 and 200. I mean, there's like 10 versions to do that. Show all strings in this list. How many polynomials in Z are in this list? At what positions is D in this list? Which companies are vinkulierte Namensaktien? And that means they have VNA in the name. Which currency does the SMI future trade in? That's the Swiss market index. That's the blue chip index in Switzerland. Which currency does BMW trade in? Give me a price chart for BMW, please. Price chart for Volkswagen between 2 and 3 o'clock. How many trades in the June expiration for the SMI? What are the BMW strikes in the June expiration? And how many June trades traded in Volkswagen? So we will make these files available. You can then download them. Mats and I will still discuss this. We'll send them to you, or you can download them from the website. All right, I see one live stream question. Why not use dataset and query by key? Those column numbers are usually frowned upon. Well, I'm going to use dataset next time, and query is used internally by dataset. And column numbers, yes, it is sometimes, but again, it's also very powerful, and it makes for a very short notation if you know them. You can do it with pattern matching and the rule replacement, as I've shown you further up when I was showing you the cases statement. That can sometimes be more robust, for example, when it changes, right? But it's also not foolproof. You can have additional columns that are inserted or deleted, and then it may break or it may not break. But part is incredibly powerful if you know which part it is, or which part you're referring to. And I've also shown you this in the polynomial example here, where part shows you the nesting level. We had this to find it now quickly. We've had it in the search for the polynomials, right here. These give you the nesting levels, and you can also get to those with part, right? You can now just use part to get to them, 1, 2, 4, 2, and so forth. So part is very powerful. Keep it in mind, but it does change the operation, the order of the operations, and can be incredibly powerful, sometimes much more powerful than pattern matching with rule replacement. Dataset comes next time. I will use dataset and key in the next session. Column numbers usually frowned upon. I disagree with, right? Not, at least not in the general sense. It can sometimes be very powerful to use part in order to get straight to the point, but it can cause breakage, right? If the table changes, then it can break. But also pattern matching with rule replacement can break then, right? It depends on which columns you're inserting or deleting. Mm-hmm. All right. Do we still have another question? We are now coming up on 60 minutes.
I guess, that was about it. So I think that's a very good point to wrap up our first session. We would like to thank again, oh, there is one more question, one comment. Yep. Yeah, we have, one comment, Andreas.
Can query take drop to make up versions? Yeah, sure. Well, Ellen, this is a beginner intro, and I'm coming to those later, right? I said I'm introducing the dataset and query later on. And I'm not going to show querying unless several people want this. I can talk about query. I've just mentioned it. I'm not going to show it unless several people want it. All right. So
okay. Very good. So that's going to be, the topic for the next time. I would like to thank again everyone for watching us live. Keep in mind that, we will upload, the notebooks that Andreas has used during his lecture, and also the homework. Thanks again, everyone.
All right. Great. Thank you.